everybody? Welcome to another video. Hope you're ready to flex those brain muscles. In this video, we're going to talk about right triangles. And specifically, we're going to talk about this acronym, SOHCAHTOA. And we're going to talk about what it means and how we can use it to do things like solve right triangles, find different values of different trig functions, that sort of thing. So, SOHCAHTOA, this is an acronym. It's a mnemonic device. It's a memory aid, basically, kind of like PEMDAS. We use PEMDAS to remember the order of operations. Or like FOIL, we use FOIL to remember how to multiply two binomials. Well, we use SOHCAHTOA to remember our definitions for sine, cosine, and tangent. So what it means is sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So now maybe you're thinking, wait a minute, I thought the definition of sine was y over r. What is this opposite, adjacent, hypotenuse stuff? Well, let's go ahead and actually, it might help to draw, let's see, y-axis, x-axis, and let's draw an angle. So this is what we call standard position. It's angle theta in standard position. And I'm going to draw a little arrow down here, not an arrow, but a line. I'm going to basically draw a triangle, right, in standard position. And remember, this is where all these values on the unit circle come from. It all goes back to triangles, so don't forget that. I'm just drawing a triangle here, nothing new. We have x, y, and r. We've seen this on the unit circle, right? And our r is 1 on the unit circle. So we have x, y, and r. So sine is y over r. And I would agree with you. If someone came up to me on the street randomly and said, what's the definition for sine? I'd say y over r, right? This opposite over hypotenuse is just another way of thinking of it, basically. It's another way of looking at y over r, where we can look at it as the opposite, right? Because this is theta, so the side opposite of theta is y over hypotenuse. So this y over r and opposite over hypotenuse is actually the same thing. What about cosine? Cosine is x over r, which is what? Adjacent, right? This is the adjacent angle over the hypotenuse. Adjacent over hypotenuse, and that's where the SOHCAH, and then this is the TOA. So y over x is tangent, which is the same as opposite over adjacent. So that's what SOHCAHTOA means. So maybe now you're thinking, wait a minute, if opposite over hypotenuse is the same as y over r, then why do I need another definition? Who cares? I don't want two definitions, I just need one. Well, it really can save you time and make your life easier. Sometimes you need to look at it in terms of opposite, adjacent, hypotenuse, that sort of thing. And I'll show you why. Here's an example. Let's say you're given some triangle like this, and you're asked here, you're given theta. Let's say this is a 3, 4, 5 triangle, and you're asked to find the sine of theta. Well, in order to use x, y, and r, I need to put this on the xy plane in standard position, right? So I need to draw my y-axis, my x-axis, I need to draw the angle here, and I need to relabel everything. This would be the 3 would be here, the 4 would be here, the 5 would be here. So I'd have to redraw the whole thing and then see, oh, this is y over r, that's 3 over 5. It saves me time and it makes my life easier if I can just use SOHCAHTOA. So I can say, wait a minute, this is my angle theta, opposite over hypotenuse. That means that sine theta is 3 over 5. So in general, usually if we're just given a triangle, like out of context, right? If we're just given a triangle and asked to solve a triangle or find the 6 trigonometric functions of theta of some triangle, right? Something like that. Just a triangle out of context, we're going to use this SOHCAHTOA way of looking at that triangle rather than thinking of it in terms of x, y, and r. So we're going to get into one example where SOHCAHTOA can really benefit us to use. All right, so we're given some angle theta and we're given two sides of a triangle. And we are asked to find the 6 trigonometric functions, the exact value of the 6 trigonometric functions of this angle theta. So this is a very common problem you'll see on quizzes and exams and stuff. And this is pretty much how they look. They give you two sides, so you have to use Pythagorean theorem to find this third side. And then you got to find the exact value of all 6 of these. So what I like to do is find sine, cosine, and tangent using SOHCAHTOA. And then I know that cosecant is just the reciprocal of sine. So I can just basically flip all these and copy them down because secant is the reciprocal of cosine, right? So really I just have to find these 3 and then I can flip them. Sometimes you may have to rationalize the denominator and do stuff like that. But it's really not too bad. But first things first, I need to find this side. So you can call it whatever, x. I mean, I'm going to call it a because in this case it actually is the adjacent side, right? This would be adjacent, this would be opposite. This is my hypotenuse. So I actually already know sine. I know that sine is opposite over hypotenuse. So sine is actually 5 over 13. And I know cosecant. That means cosecant is 13 over 5. So I guess you can go ahead and fill in the ones you know. But actually, to find the other 4, I do need that adjacent. So I'm going to go ahead and find it. Pythagorean theorem. A squared plus 5 squared equals 13 squared. So a squared plus 5 squared equals 13 squared. 13 squared is what? 169 equals 25. Okay, a squared plus 25 equals 169. I can subtract 25 from both sides. And I get a squared equals 144. And then I square root both sides. And normally when you square root plus or minus, but these are lengths, right? These are side lengths of a triangle, so obviously it's not going to be negative. So now I have, when I square root both sides, I have a equals 12. So I can go ahead and fill this in with 12. And maybe you notice that 5, 12, 13 is a very common side lengths of a triangle, so maybe that jumped out at you right away. If it did, good for you, but you can always use Pythagorean theorem. Let's see. So our cosine is what? Adjacent over hypotenuse. We have SOHCAHTOA. So adjacent over hypotenuse, which would be 12 over 13. 12 over 13. My tangent is what? Opposite over adjacent. So that's opposite is 5, adjacent is 12, so that's 5 over 12. And then I literally just take the reciprocals of these. So this is 13 over 12. This is 12 over 5. And that's it. I found all 6. It can get a little trickier as far as, you know, when you get radicals in here and there's just, you got to rationalize the denominator and that sort of thing. But hopefully you get the general idea of how to solve something like this. So most of the time, if you're using SOHCAHTOA, you're using it to solve a right triangle. This is where SOHCAHTOA really shines, and this is just where we most commonly use it, is with solving right triangles. So what does it mean to solve a right triangle? First of all, what am I trying to solve? Well, that just means to find all 3 sides, right? I'm trying to find the length of all 3 sides, and I'm trying to find all 3 angles as well. I already know one of the angles is 90 degrees no matter what, because it's a right triangle. So I'm just trying to find these other 2 angles as well as all 3 sides. In this example, I am given 1 side and 1 angle. We'll really have 2 angles, right? So I'm looking to find the rest. So typically what we do by convention is we label the angles as capital letters. So capital A is angle A, capital B is angle B, and capital C is the angle C. And what we do is we label the sides as lowercase letters, and the side is always across from its angle. And I'll show you what I mean by that. If this is angle A right here, then this is side A because it's directly across from it. This is angle C, and we normally do call the 90-degree angle C, just by convention. Most people do that. So this would be side C, and it makes sense because Pythagorean theorem, a squared plus b squared equals c squared. The c is the hypotenuse, right? So it kind of does make sense. And then if this is angle B, then this is side B. So what do I need to find? Well, I know side A is 7. I know C is 90 degrees. I know A is 37 degrees. So I need to find angle B as well as side B and side C. So how can I find angle B? Let's think about this. Well, what do I know about a right triangle or all triangles? Is that all 3 angles of the triangle add up to 180. So I have 180 equals A plus B plus C. This is true for all triangles. So if I know A and C, I can just substitute those in and solve for B, right? So just kind of jumping straight to it, I know that B equals 180. I'm sorry, I wrote 10. 180, not 10. B equals 180 minus A, that's 37 degrees, minus C, that's 90 degrees. Okay, so this is what B equals. If I do this math, let's see, what do I get? That's 127. I get 53 degrees. 53 degrees. So I found all 3 angles now. 53 degrees. Now I need to find these other 2 sides. So usually the strategy with this is I'm going to use one of my trig functions to find one of the sides. It doesn't matter which one. And then I can use Pythagorean theorem to find the last side. Because once I have 2 sides, I can always use Pythagorean theorem to solve for that 3rd side. So I'm going to go ahead and erase this scratch work here. Hopefully we're caught up to this point. So now I need to use one of my trig functions. And here's the deal, is I need to be strategic about which one I pick. I can't just go picking, I'm going to use sine, cosine. It depends on what my triangle looks like, right? and I want to strategically pick which one I use based on the definition of which one's going to benefit me the most. And I'll show you what I mean by that. Let's say I want to work with this angle A, 37 degrees. I know the side opposite of the angle A. I'm trying to find either the hypotenuse or the adjacent side. So in this case, I wouldn't be able to use something like cosine, right? Because cosine would be adjacent over hypotenuse. I don't know either of those. I'm trying to set it up, basically what I'm saying is I'm trying to set it up to where only one thing is unknown. So let's say I use sine. I use sine of 37 degrees. Which equals what? Opposite over hypotenuse. So I have 7 over c. I only have one unknown. I can easily solve for this c. And then once I do that, I can use Pythagorean theorem. So I do need to use a calculator to solve for this c. But let's see here. If I do this algebra, then I basically can multiply both sides by c and then divide by 37 degrees. So I have c equals 7 over sine of 37 degrees. Hopefully I'll see how I did that. I multiplied both sides by c. I crossed out this c, and then I divided both sides by sine. I did 2 steps in one. So now let me grab my calculator real quick. All right, so what I got from this is 11.63. So that's what my c equals, 11.63. I punched this in the calculator. And again, I could have also used, what could I have used? Tangent, right? I could have taken tangent 37 and said that's 7 over b, and I could have solved for b. What else could I have done? I could have worked with this angle, 53 degrees. And then I could have done what? Let's see. I wouldn't have been able to use sine. I could have used tangent or cosine with that. So you have a lot of options. Just make sure you pick what you're doing strategically and make sure you have the right definition. The most common mistakes I see is that someone writes cosine and they do adjacent over hypotenuse instead of opposite. So just really don't forget that SOHCAHTOA, and take your time, double check your answer. SOHCAHTOA. All right, so let's finish solving this thing. A squared plus b squared equals c squared. I'm going to solve for b, and then we're done. So let me erase this side work here. I just got to solve for b. And again, I will be making a full video on solving right triangles, maybe even a 2-part video, because it is a very common topic in trigonometry, and you do actually use it throughout math. You do use this kind of stuff in calculus with word problems and that sort of thing, so it's really good to know. All right, so now I'm going to solve for b. I basically subtract, let's see, 7 squared is 49. So I have b squared equals this 11.63. I'm going to use a calculator for this. Squared minus 49. I'm going to punch this in a calculator and see what I get. 1 second. All right, so what I got is 9.29. And now I have all 3 angles as well as all 3 sides, and I have solved my right triangle. So really, we're relying on SOHCAHTOA and Pythagorean theorem to solve these right triangles. So hopefully this video helped. Leave any questions below. Hit like if it did help you. Check out my channel. More videos. Keep flexing those brain muscles, and I'll see you next time.